Hello and welcome back to this channel. In today's video, we are going to talk about how to add vectors. We will also be discussing the parallelogram law of vector addition, and then we are going to solve 3 examples on that. So if today is your first time seeing this channel, please do want to subscribe and like the video as well. So what is a vector? A vector is a quantity that has both magnitude and direction. Now let's consider a force vector, say A, that is 100 newtons and is acting due east. Now the magnitude of this force is 100 newtons and the direction is due east. Now let's talk about how to add two vectors that are not parallel to each other. Under this, we are going to talk about the parallelogram law of vector addition. So now let's consider two vectors whose line of action intersect at a common point. So let's say we have point X, and then we have two vectors, vector A moving in this direction, and then we also have vector B moving in that direction. Now vector A and B intersect at a common point, say X. Now let's draw two lines that are parallel to both vector A and vector B. So starting from the head of vector A, let's draw a line that is parallel to vector B. So we have this line that is parallel to vector B. Now from the head of vector B, let's draw a line that is parallel to vector A. So we also have this line that is parallel to vector A. Now at this point, we have the two lines intersecting and then forming two adjacent sides of a parallelogram. So now let's call this point P. Now the diagonal of the parallelogram, which extends from point X through to point P, is called the resultant vector. The approach used to find the resultant vector is made possible due to the parallelogram law of vector addition, which states that if two vectors are drawn from a common point as two adjacent sides of a parallelogram, the resultant is the diagonal of the parallelogram. Normally, after finding the resultant vector, you will be asked to find the angle the resultant vector makes with the positive x-axis. So now let's talk about the angle properties of a parallelogram. Now let's consider this parallelogram. Now for a parallelogram, we have the opposite sides to be equal, and then they are parallel as well. Now let's talk about the interior angles. So for a parallelogram, the opposite angles are the same. So if you have this angle to be angle A, then opposite of this angle is also angle A. Now if you have this angle as angle B, then this angle is also angle B. So the opposite angles of a parallelogram are the same. Now angle A plus angle B gives 180. So angle A and B are supplementary angles. So let's apply these properties here in this diagram. Let the angle between the resultant vector and vector B be alpha. Also, let the angle between vector A and then vector B on the right side to be theta. So we have this angle to be theta, and then let the angle between vector A and then vector B on the left to be phi. So using this property, it means that angle phi plus angle theta is equal to 180 degrees. Usually, in situations where vector B lies on the positive x-axis, then the angle between the resultant vector and the positive x-axis is equal to alpha. However, in situations where vector b does not lie on the positive x-axis, you may do certain calculations to find the angle between the resultant force and the positive x-axis. So how do we actually find the resultant vector and the angle alpha in this case? So to find the resultant vector, we are going to use the cosine rule. Now for the cosine rule, we have r squared, that is the resultant vector, equals a squared plus b squared minus 2 into brackets a times b cos theta. So to find the resultant vector, we have r equals the square root of a squared plus b squared minus 2a times b cos theta. So to find the angle alpha, we are going to use the sine rule or the sine law. So we have sine alpha, and then opposite alpha we have this side, and then this side is parallel to vector a. So we have sine alpha over a equals sine theta, and then opposite of theta is the resultant vector r. So we have divided by r. So using this formula, you can cross multiply and make alpha the subject, and then you find the value of alpha. So at this point, we can take some examples. Let's solve the first example. So for question number 1, we are to determine the magnitude and direction of the resultant force. Now for this question, we have two forces. We have F1 to be 100 newtons, and then we have F2 to be 150 newtons. Now the angle between the positive y-axis and F2 is 10 degrees, and the angle between F1 and the positive x-axis is 15 degrees. Now we need to find the angle between the two forces. So the angle between the two forces is 90 minus 15 minus 10, which is 65 degrees. Now this is so because the angle between the positive y-axis and the positive x-axis is 90 degrees. So if you know the angle between the positive y-axis and F2 and the angle between the positive x-axis and F1, then we can find the angle between the two forces. So that is 65. Now this angle 65 plus theta gives 180 degrees. So it means that theta is equal to 180 minus 65, which is equal to 115 degrees. Now since we have the angle theta, then we can find Fr, that is the magnitude of the resultant force. So according to the cosine rule, Fr is equal to the square root of F1 squared plus F2 squared minus 2 into brackets F1 times F2 cosine 115 degrees. Now we have F1 to be 100 newtons and then F2 to be 150 newtons. So we have 100 squared plus 150 squared minus 2 into brackets 100 times 150 cosine 115 degrees. So you can simplify what's under the square root, and that's going to give us 45,178.5479, and then this is equal to 212.55 newtons. So this is the magnitude of the resultant force. So now let's find the angle alpha. Now the angle alpha is the angle between the resultant force and F1. So to find the angle alpha, we are going to use the sine rule. So we have sine alpha divided by, now opposite of angle alpha, we have the side that is parallel to F2. So that is sine alpha divided by F2 equals, we have sine theta, and then opposite of theta we have FR. So we have sine alpha divided by F2 is 150. So we have 150, and then we have sine theta. Now theta is 115 degrees. So we have 115 degrees, and then divided by FR. Now we had FR to be 212.55. So we write 212.55. So now we can cross multiply. So we have 212.55 sine alpha equals 150 sine 115 degrees. Now we can divide through by 212.55. So we have sine alpha equals, now 150 sine 115 divided by 212.55 is equal to 0.6396. So we need to take the sine inverse of 0.6396. So the sine inverse of 0.6396 is equal to 39.8 degrees. Now don't forget that alpha is the angle between the resultant force and F1. However, we are looking for the angle between the resultant force and the positive x-axis. Now to find that angle, we are going to add the value of alpha to 15 so that we get the angle between FR and the positive x-axis. So this is what we are looking for. Now let's call this beta, or angle beta. So angle beta, which is the angle between FR and the positive x-axis, is equal to alpha plus 15 degrees. So we have 39.8 plus 15, which is equal to 54.8 degrees. So the angle the resultant force makes with the positive x-axis is equal to 54.8 degrees. Now let's solve the second example. So for question number 2, we are to determine the magnitude of the resultant force and its direction measured clockwise from the positive x-axis. Now to solve this problem, we first of all need to draw the resultant force. So let this be the resultant force, FR. So let's draw the two lines parallel to 2 kilonewtons and 6 kilonewtons. So next, let's find the angle between the two forces. Now the angle from this point to this point is 180 degrees. You know that the angle on the straight line is 180 degrees. Now to find the angle between these two forces, then it's going to be 180 minus 60 degrees minus 45 degrees, and this is equal to 75 degrees. So the angle between the two forces is 75 degrees. In that case, we can as well find theta. That's theta is equal to 180 minus 75 degrees, and then that is 105 degrees. So this is angle theta. Now let's find the resultant force FR. So we know that FR according to the cosine law or the cosine rule, is equal to the square root of 6 squared plus 2 squared minus 2 into bracket 6 times 2 cosine theta, that is 105 degrees. Now let's simplify what's inside the square root. So 6 squared plus 2 squared minus 2 into bracket 6 times 2 cosine 105 is equal to 46.2117. So FR is equal to 6.7979, which is equal to 6.80 newtons. So FR is equal to 6.80 newtons. So now let's find the angle the resultant force FR makes with the positive x-axis. And from the question, we are going to take the clockwise direction from the positive x-axis to the force. So for clockwise, we are going to move in this direction. Now we know that the angle between this 6 kilonewtons and FR is alpha. So if we know the value of alpha, then we can subtract alpha from 75, and then we can add the value to 45 to find the full angle between the positive x-axis and FR. So now let's focus on this triangle and let's find alpha. So using the sine rule, we have sine alpha divided by, now opposite of alpha is the 2 kilonewton force. So we have 2 equals sine theta. Now sine theta is 105, so we have sine 105 over, now opposite of theta is FR, and then FR is equal to 6.80, but for the purpose of our calculation, let's use 6.7979. So we have divided by 6.7979. So now let's cross multiply. So we are going to have 6.7979 sine alpha equals 2 sine 105, and then we divide through by 6.7979. So we have sine alpha equals 0.2842. So we are going to take the sine inverse of 0.2842, and then we have alpha to be equal to 16.51 degrees. Now since we know the value of alpha, then we can subtract alpha from 75, and then we add up to 45. So let the full angle between the resultant force and the positive x-axis be beta. So we have 75 minus alpha, which is equal to 75 minus 16.51. So 75 minus 16.51 is equal to 58.49 degrees. So beta is equal to 58.49 plus 45 degrees, and this is equal to 103.49 degrees. So this is the angle between the positive x-axis and the resultant force, taking your reference point from the positive x-axis and moving clockwise to the force. So now let's solve the third question. So for question number 3, we are to determine the magnitude of the resultant force and its direction measured counterclockwise or anticlockwise from the positive x-axis. Now we have these two forces, 800 newtons lying on the positive y-axis And then we also have the force 600 newtons, that is 30 degrees away from the positive x-axis. So let's draw the resultant force. So we have the resultant force Fr here, and then let's try to draw the parallel lines. Now the angle between the positive y-axis and the positive x-axis is 90 degrees. So 90 plus 30 is 120 degrees. So the angle between the two forces is 120 degrees. And then the angle between Fr and then 600 newtons is alpha. And then we also have theta here, which is equal to 180 minus 120. And then you have theta to be equal to 60 degrees. So now let's find the resultant force Fr. So the resultant force is equal to the square root of 800 squared plus 600 squared minus 2 into bracket 800 times 600 cosine of 60 degrees. So when you simplify what's under the square root, you have 520,000, and then Fr is equal to 721.11 newtons. So this is the magnitude of the resultant force. Now let's find the angle the resultant force makes with the positive x-axis if we are moving counterclockwise from the positive x-axis to the force. So this is the angle we are looking for. Let's call this angle beta. Now to find angle beta, we basically need to find the angle alpha, that is between Fr and then the 600 newtons, and then we subtract 30 from alpha to get beta. So let's find for angle alpha. Focusing on this triangle, we have sine alpha divided by 800 equals, we have sine theta. Now theta is 60, so we have sine 60 divided by Fr, that is 721.11. So we have sine alpha to be equal to 800 sine 60 divided by 721.11, and then sine alpha is equal to, now 800 sine 60 divided by 721.11 is equal to 0.9608. So we are going to take the sine inverse of 0.9608. So alpha is equal to 73.90. That is the value or the angle alpha. Now because we are interested in finding beta, the angle between the positive x-axis and then Fr, now beta is equal to alpha minus this 30 degrees. So we have alpha to be 73.90 minus 30, which is equal to 43.90 degrees. So this is the angle between the positive x-axis and the resultant force. So that's it for today's video. If you like the content of this video, feel free to like, comment and share among friends. Don't forget to subscribe to receive more interesting videos. Hope to see you in my next video. Bye bye.